The normal distribution. So this curve is called the normal distribution, and it's called normal because it's what you normally expect to happen. It's sometimes called the bell curve or the Gaussian distribution because a mathematician called Carl Friedrich Gauss discovered it. And you can see it's symmetrical around the thing, the mean. The mean is this thing, x bar is the mean, and all these s's, they're the standard deviation. Okay. So you can imagine in a situation where, say, if I gave you some values and I said, okay, so x bar, that equals, say, 50, and just standard deviation s for sample is 10, then we could say that this point is 50, and then plus one lot of standard deviation would be 60, plus another standard deviation 70, and you can just see we're just adding 10. And 3 standard deviations, we're adding them on, so that's why I say this plus symbol gets you to 80. And then we're minusing 50 minus 10, so that's going to be 40, and then minus another 10, 30, and minus another 10, 20. So you can see how you place these values on there, and that will really help you with some of the calculations you have to do later. So one thing to note is that as it is all symmetrical around this lovely mean, then half of your values are on the right and half of the values on your left, or 50-50 in the percentage terms. Okay, on the normal distribution, if you were to look at this entire area here, we can see that's between +1 and -1 standard deviation, and that represents 68% of all your values. All right. If we were to do a similar thing, but this time color in all of this area, you can see that goes from +2 to -2, and that represents 95% of all values in a normal distribution. And then finally, of course, +3, -3, that's all this area. All that, going to do some nice coloring in there, and all the way up to there. Nice coloring in. That's 99.7%. You can see that in that green writing squeezed in there of all your values. These are useful things to remember when you get to problems, example problems coming later. Or you can split it into little segments. So you can say this little bit going on infinitely forever, by the way, represents 0.15. So that's less than 3 standard deviations. This little bit is 2.35, and it's got a symmetrical partner over here in each of these cases. That's another 2.35, so it's 2.35 on the negative side and 2.35 on the positive side. And you can see there's also, you can have 13.5 here, 13.5 here. This is between 1 and 2. And there's the 2, there's the 34. Here, there's another 34 here, because remember they add up to 68. So this is all the same information, it's just cut up in different ways. And then you can look at it in all its glory with all the information squeezed onto one lovely, neatly drawn diagram. You definitely need some sort of diagram like this in your book. You might want to separate out into 3 or 4 different versions of it, but you can see this is going to be very useful to quickly answer many questions. So anything that is normally distributed, these rules apply to. So in this case, we've got this skinny guy over here, right? Now that skinny guy, it's skinnier because the standard deviations, these little distances, are shorter, whereas this fat guy, the standard deviations are bigger, but they are all exactly the same. So all those areas still work out in the same way. So there will be 34% of values here will still be 34% of values here of all your values. So that still works no matter what, how spread it is, as long as we're still talking about standard deviations. That's the joy of standard deviations. Now, the key phrase to watch out for here is the phrase approximately normally distributed. Now, this is a key phrase that comes up a lot in questions. So if you ever see this phrase, it means you're doing something like this or z-scores, which will be explained later. Okay, here's a lovely question, and it says that lovely key phrase, approximately normally distributed. That means we're going to have that lovely graph redrawn perfectly down here, and it says the mean of 70 minutes. So that means down here the X bar is 70 and standard deviation of 2. So we're going to say plus 2, so 72, plus 2, 74, plus 2, 76, minus 2, 68, minus 2, 66, and minus 2, 64. All right, what's the actual question asking us? It wants the percentage. That's nice. Pay attention to that. Between 66 and 72 minutes. Here's our 66. Here's our 72. So we've got to add up all the areas in between those two things. So quickly we can see that the light blue thing says that's 68, and this little bit more we need is 13.5. And so we just need to add those two together. So 68% plus 13.5%, that equals 81.5%, and that equals an answer of D. And you can see they often do these sort of asymmetrical ones to try and throw you off a bit. We just have to add up the chunks of the diagram that you need to make the whole picture. And you can do it any way you like. You could do it on 13.5 plus 34 plus 34, but you know, same diff. Okay, this one, they've said it is normally distributed. They've got to say approximately. Apparently it's very precisely normally distributed. Same thing, we're going to have a look at our diagram. We've got a mean of 240 and a standard deviation of 5. Now I'm just doing this slowly by putting all the values in here, but there's our mean, 240 plus 5, 245 is 1 standard deviation, 250 is 2, 255 is 3, 235 is 1, 230, it's very hard to write on this screen by the way, 225, that's my excuse. All right, so we want to know, and it says here, says 160 cups of soup. We haven't shown you how to do that yet, but the number of cups of soup that are expected to contain less than 230 mils. So that less than 230 mils is this area here. So we started at 230 and went less. And you probably should know by now that this area, it adds up to 2.5%. But it's of this 160. So it's 2.5% of 160, which equals 2.5% of 160. And if you do some quick maths on that, you would get B, 4. So remember, the key thing here, it wasn't asking for a percentage, it was asking for a number, and we've got a number. And percent means per cent, and of means times. All right, still the same data in all these questions, but it says approximately normally distributed, mean of 69, standard deviation of 4. So we know that's 69. This is 73 because you add 4, 77, 81. This is 65, 61, and this is 57. All right, now again, we've got that idea of we've actually got 200 students. So you're going to do that multiplying thing, and it's the number of students with a pulse rate less than 61 beats or greater than 73 beats. So less than 61, that's this area, because we go 61 less, and then it says or greater than 73, which is this area. So they're done it lovely asymmetrically for you. You can add them up. This bit's 2.5, this is 13.5, plus the 2.5, because 2.35 plus 0.15 is that 2.5 plus 2.5 is 5%, plus 13.5%, that gets us 18.5%. And remember, it's of these 200, so of 200, that equals 18.5% of 200. Multiply that all together, it's just 2 times 18.5, which is 37. Answer is 37. You can see they love these questions, approximately normally distributed, with a mean of 78.6 and a standard deviation of 9.3. So you're going to have to get a bit more sort of decimal with this one. Now we've got 78.6 here, and then you have to add 9.3. Okay, now, and in no way did I pause the video and do this on the calculator. So this should be plus 9.3 is 87.9, plus 9.3 is 97.2, plus 9.3 is 106.5. You'd have to mark them all out on these things. Just doing this for fun. 69.3, there's 60, which I think is a key value highlighted up there. You don't have to find out where the 60 was really, you don't have to do all of these numbers, but just for completion, 50.7. And so it wants a weight, now it wants above 60 kilos, so 60 kilos is here. That means all of this area colored in there. And again, this is a classic one of, we know this is 2.5 and the whole thing's 100, so the rest of this is 100 minus 2.5, so that's actually 97.5% we want. So we want 97.5% of 456. That equals 97.5% of 456. Now you can get a bit of a feel for where the answer is going to be on this. This is the majority of 456. So it's not 3, it's not 11, it's not 23, is it? It's either going to be 433 or 445. Now if you actually hit your calculator, you get 444.6. That rounds off to pretty much 445. So that's your answer.